So hello friends, let me introduce myself. I am Dr. Latesh Malik, working as Associate Professor at Government College of Engineering, Nagpur. I am going to take your database management system and I will be preparing you for DBMS course and for the gate. So we will be taking purely towards the gate preparation, and we will be taking some of the problems and their solutions. So before I would like to take the theoretical part and clear your concept, and after each and every concept we are going to take the gate problems. We will be discussing the solutions for every topic. So let me start with the syllabus of the gate. This gate syllabus of DBMS consists of entity relationship model, relational model. Under the relational model, the uh, topics are the relational algebra, tuple calculus, SQL, integrity constraint, and the normal form. Then some file organizations, B and B plus tree, which is indexing. And the last topic is transaction and concurrency control. So we will be only focusing on the concepts, and we will be leaving the theoretical part, and our objective is to prepare you for the gate. The additional e-learning sources that you can refer for the DBMS is you can join to the SWAYAM course, which is offered by NPTEL, and they are offered by the IITs. So this DBMS course is available in current semester also. You can go into the detail by joining this course also. And other, you can use the spoken tutorials for the practical, but I think for the gate we do not need any practical exposure. We will be learning only the concepts. So before moving to the first part of the ER diagram, today we will be discussing the few terms which are the basic terms you need to know before studying the database management system course. The DBMS is that you have the collection of data and you need certain manager who is going to manage your data. So you can say that the DBMS is the collection of interrelated data, and you and the set of programs which are going to manage that data. At the same time, additional an environment is required for the convenient and efficient use. So the combination of these three is DBMS. The database, different applications can be generated on the databases like banking, airline, universities, sales, like this. So we will first learn the basic terminologies or the basic concepts which you can say which evolve the DBMS. Earlier to the DBMS, there were the file systems. As you create in the C language, different file systems, but the file system cannot handle each and everything or large databases or the requirement of our applications. That's why the DBMS systems are evolved. Which were the problem that were faced by the file system were: the first is the data redundancy. The data redundancy means that we have to store the data for multiple number of times in many of the projects. But the redundancy means that everywhere the same data has to be reflected in the same way. And the requirement of DBMS is that one data should be stored only at one place. The duplication of data should not be stored, because the one problem which is that it is waste of space. So we need data redundancy problem has to be overcome, which was present in case of file system. And redundancy, with the redundancy, one more problem occur, that is a inconsistency. Inconsistency means if you are changing the data at one place, and you forgot to change the same data at the another place. Say for example, you have saved the same data at two files, and you have changed the data in one file, and you forgot to change the data into the another file. You can see that it is a lot of inconsistency. So this is inconsistency. Why you got this inconsistency? Because data is redundant. So if you remove the redundancy, inconsistency problem can also be overcome. The more problem for the file system was, it was difficult to access the data. Every time you need to open the file, go to the end of the file, then you have to access the data. So this problem can be overcome if you use the database management system. A data isolation means you have to store the data into the multiple files and the multiple formats they are available. How can you integrate them into one platform? And integrity problems is, sometimes we want to check our data. Say for example, the age should not be more than 100 years, or balance should always be more than 0. Such type of checks that you need to check is integrity. So this integrity, you want to check certain checks that is allowed in the DBMS system. But it's the same task if you have to do in the file system, it was very difficult to check your data. So DBMS is very, very useful to handle the data in an efficient way. The example of database management system is Oracle, Postgres, SQL Server, and many more. If you store the data into the database, the data can be stored at the different data is stored in the hard disk, but you can see the data at different level. A different level means the data is actually, you are storing your data into the hard disk, and internally it is using certain format to store your data into the binary format. This we call it as a physical level. We are storing the data physically into the hard disk, that is a physical level. But in case of logical level, we can see the data like this. The logically related data we can see in the form of record. Then we say that it is a logical level. The data is not stored like this, but user want to see the data like this. That's why it is called as a logical level. So data of DBMS is giving it as a definition of logical level. If you store the data which is logically related to each other like this, then it is a logical level. And the view level is the user can view the logical level. Above the logical level, user can have the different views. Say for example, one user would like to see only the ID and name, and the second user would like to see name and department, like this. The different views can be created over the logical view. You can see that on the hard disk level, you have a physical view. On the other way, above the physical level, you can have the logical view, and above the logical view, you can have the different view levels. So DBMS will give you the view up to the logical level, and physical level is managed by the DBMS. It is not accessible to the users. So during this course, we will see that the data can be stored in the form of relation, that we call it as a relational model, where we store the data in the form of table like this, and logically it is one table, and we are storing the data like this. It is a relational model. The relational model has the number of rows and the number of columns, and you can store the data like this. This is again a sample relational database. So in the relational database, you can write certain commands or certain instructions. These instructions are divided into two parts. One is a data definition language and another is a data manipulation language. The data definition language says that you are creating the tables, you are directly managing the structure of the table. It is not dealing with the data, you are only dealing with the definition of the table. That's why it is called as a data definition language. Under this DDL, the some commands like you can create a table, you can delete a table, you can remove a column like this. You can update the column name like this. We can basically change the structure of data, structure of a table. Then it is called as a data definition language. One of the command of data definition language is like create table, and you can have the different column name and their types. So different commands comes under the DDL. We will learn under the SQL what are the DDL commands and how to write them. The second type of commands are data manipulation language. Under the data manipulation language, we will learn how to write the queries, how to extract the data, and different type of retrieval comes under the manipulation language. We can update the table, we can insert the table, insert the row. That is under data manipulation language. So in this course, the SQL is the language to support the data definition and data manipulation language. We are going to learn SQL in detail. Many of the questions are asked on the SQL in the gate questions of DBMS. So we are going to do SQL commands in detail. To design a database, that it support the two type of designing. The one design is you can have the logical design and you can have the physical design. So to learn the design process, we are going to learn the ER diagram as well as the normalization. ER diagram will give us the graphical way of representing the data, and normalization will give us how many fields has to be kept in one table, and how to split the table, how to merge the table, and how can we represent meaningfully the data into the different table. That we are going to learn under the normalization. So the two design approach we are going to learn, one is the ER model and another is the normalization theory. So we will not be doing each and everything. I am focusing only on the part which is related to the gate. We have to understand the basic architecture of the DBMS. The database management system is on the top of the layer. We have the different application programs. We have the different users. What are the different users? You can say guest, admin, and different programmers, or the system administrators are the different users. So these users are interacting with the application program, with the query retrieval tool, with the different administration, and with the different interfaces. It is dealing with the database. So DBMS is handling these two parts, the users and the administrators are handled by the DBMS. You can see it is a detailed diagram of DBMS. ये जो whatever is there into the rectangle, the rectangular part is handled by the DBMS. So we can, different users are giving the commands to the DBMS. We can use, what are these? These are the different, say for example, Postgres, Oracle. These are the different environments where the direct users can directly communicate with the DBMS, and the DBMS is handling the query processing, it is handling the storage manager, and it is handling the disk storage. So these all parts are automatically handled by the DBMS. This was absent in case of file structure. That's why you can see that everything, this DML queries, compiler, linkers, query evaluation engine, query processing engine, different authorizations, different integrity constraints, different transaction managers, different buffer managers, they are the part of DBMS. So DBMS is holding a lot of responsibility to free you from the many of the overheads related to the data. So we will not be going into the, now I am doing the next part of this, next part of so we are starting with the relational model now. Today we will be learning the theory, and from the next class we will take the problems based on the part which we have covered today. In the relational model, you can represent the data in the form of relation. The relation is a table which consists of rows and columns, and you can store the data in the form of table like this. One row is called as a tuple, and the attributes are called as a columns, and the combination of attribute and the tuple is a relation. You can see that why it is named as a relation, because all the related data is stored in one table. ID 101 data is stored in one row. ID 121 data is stored in second row. So all related data is kept in one row. That's why it is called as a relation, one row. Now we will see the attribute. The attribute is a column where you can have the attribute name, like what are the attributes? ID, name, department name, and salary. So we will be learning the theory related to the attributes. In the attributes, every attribute is associated with the domain. What is the domain? Say for example, different ID number ka jo bhi, whatever is the combination of different ID number, or what are the possible ID numbers, is a domain of ID. What are the possible names in the world are the domain of name. What are the possible department are the domain of department name. Whatever is the possible numbers, that is a what integer numbers, is a domain of a salary. So for every attribute you have to associate a domain. It will take the values from the domain. So you can say that it is some of the values you have taken from the entire domain of ID. So we have seen what is domain. The second is atomic values. Atomic values means every, you can see that this is ID number is an atomic. You cannot subdivide this ID number into the different fields. This Srinivasan name is an atomic. You cannot subdivide this name. So every value of the, or you can say every cell in this table should be the atomic one. It is the part, it is a definition of relation. It should be atomic means non-breakable. It cannot be broken. And the domain can also have the null values. Sometimes sometimes we do not get the value. Say for example, I do not know the name of a particular person. I do not know the department name of a particular person. how should I represent its department name? Say for example, I do not know the department name of Srinivasan. So I will be storing the null value because I do not know. So null values are allowed and null values represent that the values are not present. The null values are not very, you can say they are the unwanted one. It should not be present. Null values should not be present because it confuses the user, it confuses the database as well. But when you have no values, you have to represent the null. Now we are coming to the definition of a relational schema. The definition relational schema has to be represented as R is equal to A1, A2, AN. It says that A1 is an attribute, A2 is an attribute. So relation can be represented as instructor is equal to ID, name, department name, salary. So you can represent the relation schema like this. And these values, the ID values will come from domain D1, name values will come from domain D2. Then you can see that what is the total domain of this relation. So the total domain of this relation will be D1 into D2. That is a Cartesian product. D1 Cartesian product D2, Cartesian product D3 Dn. So D1 is domain of ID, D2 is domain of name, but the combination of D1 into D2 Dn is domain of relation R. So you have to see this, it may be the question. D1, how do you represent the relation and what does this D1 into Dn into represent? Now, what is an instance? The instance of a relation is one. So you can say one row is one instance. So you can see this first row of Srinivasan is one instance of this relation R. So instance is one relation. The tuple is also a row. Tuple is also a row. In the relation, whatever entries you are representing, the order is not relevant to us. As we see in the case of set, set mein the order is not relevant to us. Who are the member of the set is relevant to us. The same theory is applicable to the relation as well. In this relation, the order of rows is not relevant to us. Only which are the rows present into that relation is matter to us. Say for example, in the previous case 10101 was first row, but in this case it is in 10th row or so, but both of the relations are same. So order is irrelevant to the relation, it can be in any order. Now we will come to the keys. The keys are used to identify the rows in the relation. To identify the rows in the relation means, if you have been given this table, how can you identify this row, individual row? You can identify the row by using a attribute or set of attribute which are unique. If you see this in this table, the ID numbers are unique, then the ID is a key. How key is used to identify an individual row in the relation? The key has the different definitions. Keys are of three types, or you can say there are multiple terms of the to represent the keys. The first term is a super key. The super key says the super key means the attribute or the combination of attribute which can be uniquely identify a row. In the previous case, the ID is uniquely identifying the each and every row present in the table, but the combination of ID and name will also uniquely identify. If I say my roll number is 20 and it is unique, then my roll number and my name will also be unique. So both of them are the super keys. The super keys is an attribute or a combination of attributes which can uniquely identify a row in the relation. Now we will come to the candidate key. The candidate key is candidate's key is the minimal super key. The minimal super key means in the previous case ID is uniquely identifying a row, and ID and name is also uniquely identifying the row. The minimal set of attributes which can uniquely identify a row is ID. So ID will be a candidate key. This ID comma name will not be a candidate key because it is not minimal set. It is a combination of name which is not at all required. It is not a minimal set. So id के साथ if you can id comma name, id comma department, id comma name comma department, id comma salary, all of them are super keys, but the minimum set of attribute is id, which is identifying this row, is a candidate key. So id is a candidate key, but id comma name, id comma name comma department is a super key. Now, what is the primary key? The primary key is out of whatever candidate key you have selected, there can be the multiple candidates key of a row, but you have to select one to identify the row in the table. Every key cannot be selected. Out of the multiple candidate keys, you have to select a one candidate key for your relation. So whatever you are selecting, the one for your table is a primary key. Say for example, in the diagram, if you say the ID is a candidate key and name is also a candidate key. In this case, a name you can take because name is also unique in this case. So if you say the ID is a candidate key and name is also a candidate key, but you have to select only one. So say for example, you selected only ID to identify the rows, then it will be a primary key. So primary key is whatever key you have selected is a primary key. Now we will see the foreign key. The foreign key says that K the foreign key says that you have to take the two relation, and in the two relation, if the same attribute is present into the two relation, then if a field, if a attribute is common in two relation, uh, the attribute uh, which is the attribute which is a primary key in one relation, and the same attribute if it is present in the second relation but it is not a primary key, then you can relate these two relation by using the same key. The key which is present in the table which is not primary, second table, we call it as a foreign key. We will be taking this in the detail in the future lectures as well. So foreign key require a two relations and you have to reference from one relation to the another relation. So we will take one diagram. This will clear you related to the DBMS concept. Say for example, we have some students. In the students, you can have the different fields like ID, name, department name, and other field, uh, credit system or total credit or so. So this student is one relation, and you have underlined this ID. This ID is a primary key, and uh, there can be the multiple tables like this, and you have to underline the primary keys. You can see that in this table the combination of 4 is a primary key. In this table the combination of 2 is a primary key. So if you want to store the university, if you want to store the data into the university system, you have to create the data of classrooms, section, takes, different time slot, teachers, course, department, instructor, advisor, and so on. And you have to identify the primary key for each and every relation. Now we will see how can you relate the two tables, how you can draw a line like this, how to draw a arrow from which direction to the another direction. So look at this, we take these two tables. This table is a student and this table is a department. You can see that the main information of department is stored here and the information of student is stored here. The student is part of the department and you can see that department name is common in these two tables, but the department name is a primary key into this table. So it is going to take the information of department from this table. These two tables can be joined by using this common field name, which is the department name, and department name is a primary key here. So if department name, you can see that this arrow is from department name. It is referring to this department name. So this department name, student, whatever is present in the department name is a foreign key, and the department name of the department table is the primary key. So foreign key is always going to refer a primary key and arrow is going to be there in the direction of the primary key. Means that it is a foreign key or foreign key is referring to the primary key. So you have to combine the table like this and you have to put the arrow like this. Look at this. This course ID is a primary key and it is referring to the course ID this course ID is foreign key here and it is referring to the course ID of primary key here. What iska primary key kya hai? The primary key of section is the combination of four fields, that is course ID, section ID, semester and year. Combination of four fields is a primary key of section. So you have to combine like this. It is an ER diagram. So now we are starting with the relational algebra. A relational algebra is the relational algebra is a mathematical way to represent your query language. The mathematical way to represent your query language means we will be using the mathematical symbol to represent our query. So we start with the select operation. The first operation that we are going to learn under the relational algebra is select operator. The select operator will select some of the rows from the table and the select operator is represented as, you have to take the select operation as sigma. Under the sigma, you have to write the logical formula, and in this logical formula, you have to use the column names or attribute names, and you can apply the condition, you can check, and always you can see that whatever formula you write here, its value will always be true or false. If the value of this formula is true for any of the row, then that row will be displayed, and in bracket you have to write their relation name. So I again repeat, sigma condition, which is a subscript, and on the same level you have to write the name of a relation R that will extract the sum of the rows from the relation. So look at this query. We have been given a relation this, This relation has 4 rows. From these 4 rows, you have to take the rows whose value of A is equal to B. Now you can see which value is equal to A and equal to B. So you can see that which rows has the value of A is equal to B. This row has the value A is equal to B, and this row is have the value A is equal to B. This row has the value A is equal to B. Now look at the second condition. The second condition take, it is AND. The second condition take, you have to take the rows which has the value D greater than 5. Now we will see only these three. D greater than 5, it is true. D greater than 5, this row is not under consideration. This row is under consideration, but D, value of D is not greater than 5. So we will leave. The value of D is greater than 5. So you have to take only these 2 rows in the select operator. So you can see that both conditions are AND. So first you have to apply the first condition, and then out of the selected rows from the first condition, check for the second condition. The rows which pass both of the conditions together, only that rows will be retrieved. So you can see the result of this select operator will be these 2 rows. Now we will come to the project operation. The project operation says you have to select the vertical. In the previous case, we have selected the horizontal. Horizontal means we selected the whole rows. Now we will be selecting only some of the columns, which is a vertical selection. So vertical selection is, it is a vertical selection. The vertical selection is a project operator, projection, right? How to write the project? You have to write this pi. The subscript is which column you have to select, A, C, and on the same level you have to write the name of the relation, that is R. So it says that you have to select A, C. I do not want to take B. So it is a vertical selection. You have to take A, C like this. So you took A, C, but the redundant rows are not, they are automatically deleted. So you can see that alpha 1 and alpha 1, they are redundant. They will be automatically be deleted. It will be converting into one row only. So your data will be like this. It is a project operator. The selection was a horizontal, you can say horizontal filter, and the projection is a vertical filter. Now we will see the union of 2 relations. Previous 2 operators were the unary operators. They were applicable only to the single row. Now it is a binary operator. It needs 2 relations, R and S, and you can apply the different one of the operation as a union. The union is same as you do in the case of set of union. Now we are applying it to the relation. So relation, the union says that the values which are present in A or B or in both. So you have to take R and S, and you can see that whenever you apply the relation R and S, the columns of relation R and S should be same. If they are not same, you cannot do the union. They should be the same. So you can see that their names is same, their cardinality is same, and their sequence is order is also same. Now we will take union. Union says if it is present in either A or it is either R or S or in both. So you have to take first alpha comma 1, then alpha comma 2, then beta comma 1, then alpha comma 2 has already been done. So we will not be taking it again. Then beta comma 3. So you have to take these 4. Redundant entries are automatically deleted, so they need not to be written again and again. The next binary operation is that is a set difference. The set difference says that it is present in A but not in B. That is a set difference. So you have to take, this is again a binary operation. For every binary operation, it is the condition that both relations should have the same attributes. So it is a binary operation, and you have to take all the rows which is present in R, not in S. It is represented as minus sign R minus S, and you have to take A minus B, which is alpha comma 1. It is present in R but not in S. You can take this. Alpha comma 2, it is present in A but it is present in B, so you cannot take this, which is present in A, not in B. Beta comma 1, it is present in R, not in S, so you can take. So only 2 rows will come. It is a set difference or a minus operation, A minus B. Again, the another binary operation is a set intersect operation. The set intersect operation will take the common entries which is present in R and S both. R and S. You can say R and S both, right? So you can see that it is present in alpha comma 1 is present in both. No. Alpha comma 2 is present in both. You can take. Beta comma 1 is present in both. No. So you cannot. So only the common entries has to be taken. If you see this, whatever result you received, this formula can be written as R minus S. It is an important from gate point of view. Look at this. R minus S. You can solve it. R minus S. What were the entry in the R minus S? You can see that R minus S is present in R, not in S. So this is present in R, not in S. Present in R, not in S. R minus S. This is R minus S. If you subtract from R minus S, you are going to get the second row. So both of them are same. Intersection can be written like this. You have to see this. R minus S. Now we will come to the Cartesian product. The Cartesian product is again a binary operation which will take all the combinations from R and S. But in this Cartesian product, you can have the different attribute names and the sequence as well. It is again a binary operation, but both of the attributes and the sequence is not required to be the same. The Cartesian product says that it is going to combine a row with each and every row present in table S. So alpha comma 1 will be combined with each and every row present in table S. So you can see that alpha comma 1 is combined with first. Then you can get this. Alpha comma 1 is combined with second. Then you can get like this. So you have to combine with all alpha comma 1 like this. Now you have to take the second row of R. Again combine them with all the rows present in S. So you have to take the second row, combine them with all the rows present in table S like this. So you can see that if you have the 2 rows or the 2 tuples in R table and 4 tuples in S table, then finally you can get the 2 into 4, that is 8 tuples. The 2 into 4, that is 8 tuples in R into S. This question is again asked in the gate. If you have n1 rows in R table and 2 rows in S table, then finally Cartesian product will consist of the number of n1 into n2 rows. So in the Cartesian product, if you have the same column name, how can you say that if we are going to get in the Cartesian product, we are going to get combination of all the columns. Look at this, A, B, C, D, E. Finally, you will have the table of A, B, C, D, E, and you will have the 8 number of rows. Now, if you have the column, if you have the common column name, how can you say that this column name is of R and this column name is of S? So if you have the column name same, in case of a Cartesian product, the same column name is prefixed by the name of a table. Say for example, this B attribute name of R table and this is a B attribute name of S table. You have to do this only for the columns whose column names are same in two tables. Now we will see how can you rename a table. You must be knowing of renaming a file, renaming a image. The same concept is applicable to rename a table. How can you rename a table? To rename a table, you have to use operator row and you have to give the new name. The new name is given as X and the old name is E. This E table name or a relation name is renamed as X. This is a renaming operation. Look at this example. The table R has two attributes. Now I would like to rename it. So I have renamed this table R with a new name which is S. So you can see that this is relation R. The same table again exists which has A comma B and it is renamed as S. It is S. Now you have to do the Cartesian product between these two. Renaming means data is going to be the same. So you have to do this A and B, and with A and B you have alpha comma 1 and beta comma 2. Beta comma 2. Now you have to do the Cartesian product. To do the Cartesian product, you can see that the field name is same in case of R and S. So you have to prefix it with R dot A and S dot A. B is also same, R dot B and S dot B. Now you have to do the Cartesian product. The first row has to be combined with these two and the second row has to be combined with these two. So you will be getting the 4 rows. So this is the renaming. The rename operation is used whenever you want to do a operation of the table with itself. Say for example, I would like to find out within a table of say for example employee whose salary is maximum. So I have to compare the salary with itself salary. Means you have to do the operation of table with itself. So you have to at that time you need a renaming of a relation. Whenever you want to do the operation which needs certain comparison of data, operation to itself is it require a renaming a table. You can also do the composition of the different operators. The different operators composition means you can do the Cartesian product. Over the Cartesian product, you can do the selection operation. So multiple operations can be combined. You can do the union. After doing the selection, you can do the union. You can do the projection. At any stage, you can combine the various operations. But you have to see that you are doing in a logical way. How does these operations are calculated? These operations are calculated like first your bracket will be calculated and then after this bracket you are going to create a new relation. This relation will consist of R into S. Out of this new relation you have to apply this horizontal filter which is a select operation and you can apply the condition of a select operation. So look at this example. R into S will result in this table. In this R into S, you have to apply A is equal to C. Now you have to take the rows which has A is equal to C. Look at this. A is equal to C. Look at this. A is equal to C. Look at this. A is equal to C. So only 3 rows will be filtered and you can get the result like this. So you have to first do the operation on the braces, apply the resultant relation, and then you can apply the horizontal filter. So that is it for today. We will continue in the next class. So thank you all. We'll see you in next class.